Hello guys and welcome back to Mr. P channel on YouTube again. So I haven't posted any videos so far in this few weeks because I was a bit busy with my job that I forgot to tell you guys that I just got a job as an electrical engineer in a place in a company located in my city and also this is my first official job as an electrical engineer. So today I got a free time that I have to do the demo for you guys because a lot of people have requested to see the demo. Also some people request me to do a tutorial on how to communicate between the microcontroller to microcontroller or between the microcontroller to the app on your smartphone or tablet where it can communicate, transmit and receiving data from each device like that. So now this is what you are going to see and this is what actually you are looking for so far. So here is the hardware that I have built by my own. The code, everything, the sensor, everything is built by my own, but not this one. This is the ESP8266 that it is take more time to build by my own, so I decided not to take my time doing it. So I decided to buy it directly from online shop Taobao from China. And also actually I have built one, no not one, I built 3 devices, the ESP8266, and I also have the footprint, I mean the schematic board, everything designed already by me, but I'm not using my own design for this one because I think the standard one might work pretty well. So here is the hardware and here is the software. It actually not a software but an application which is made it by myself as well. It working on iPhone, iPad, everything, but now I run it on simulator because I have my iPad in here also. But a few weeks ago I do the test run and it worked pretty well, but after a week later it is not, I mean it's unable to run the application. I'm not sure whether it is a account problem or a certificate problem with Apple, so I'm gonna leave it right there, but I'm going to run a test on simulator on my Xcode 8.0. So here's the hardware and here is the software that I built by myself. All was built by myself. So let me do the demo. Let me introduce some of my component in here. So here is the hardware part where it have the ESP8266 that I use as a Wi-Fi module to connect to the internet, and this one is the 8T51 microcontroller where is we kindly said it's a brain of all. And also this one is the humidity and temperature sensor where you get the temperature, the live temperature and humidity. And also here's the photoresistor. It's a light resistant. It resistant to the light, whether it is dark or bright, it will lights up the application. So I got 4 photoresistant device in here, 4 photoresistant sensor and Wi-Fi module, a microcontroller and a humidity temperature. So how it works? Well, here is the main code, the main brain, the 8T51 microcontroller where it coded to let the temperature to obtain the right now temperature and humidity and then send the data to this one, and then this 4 device will detect whether there is a light on or off. For example, a lamp or any kind of light. Yeah, maybe a lamp. Well, there's a lamp in your house and then you want to know whether it is off or on. Well, this sensor read it all and pass back the data to the brain, so that the brain in here 8T51 will pass the data to 8266 where the data that have been passed into 8266 will continue passing through Wi-Fi that connected with this Wi-Fi module into the internet, into the server, and then the server itself will continue passing the data into the subscriber package, the subscriber application. For example, this application as run as a subscriber and publisher. So when the data pass into this one pass into the internet will pass the data into this one, so that it will display the temperature and also the light state of the lamp. But this one also work as a publisher, where it pass the command to the ESP8266, and then the command that when 8266 receive the command, it will continue pass the data into the brain, where the brain will trigger some action. For example, turning on an LED on and off. 4 LED in here that I have coded, so it will trigger from this. It will pass the command from here to here, and then go direct into the brain, and then the brain start to trigger some action like giving light on, so lights off. So let's not wasting our time, and let's do the demo. So here's the demo. Let me get into the app first. Application. So let me go to home. Okay, so after let me like that. Okay, now here I have on my iPad home screen, for example, because this is a simulator, it's not a real iPad, but the app itself is real. So now let's get into our app. It's called Home Automation. It's a home automation app that I have built by myself. It's not look really standard, but I try to get it standard. So once I finish everything inside this app, I will publish this app into App Store, so people can download it and enjoy it for free. And I am going to do the tutorial also on how to code for this one, and also how to code for this one, and also how to make two of this thing combine and work together. But let's not talk about it right now, and talk about this one instead. So okay, now we're on our app, so click on Get Start. Now we're gonna go into auto mode, where everything has been configured, include the IP address, including the server, everything. So get control room A. Okay, let's see how the data pass. So now the temperature right now is 28 Celsius and 64% of humidity, where it read from this one. So let's say I want to trigger an action like turning on an LED. So I'm gonna press on this button, on button. Okay, so we will see okay, now it's lights up. So let's get started with another one, LED 2. Okay, alright, the second one lights up. Let's get into LED 3.
It's 10 o'clock.
Not sure it's gonna lights up. Oh, okay, it's already lights up. There you can see the blue one. It's not so bright. Okay, so let's get into number 4, LED 4. Okay, so now we got 4 LED turning on. So imagine that this LED is a lamp. So once you turn it on, the lamp will brights up, so that our photoresistor that putting nearby the lamp will read the brightness of the lamp, so it will tell us whether the lamp itself is turning on or turning off. So imagine that this is putting nearby the lamp. So for example, the lamp right now is actually on. Actually, we got the LED turned on, so imagine that the lamp is turning on. So the lamp on, and we're shining into the photoresistor sensor, where it read and tell us that the LED 4 is actually turning on. So let's say I'm turning it off, and yep, the lamp is actually turning off. So let's turn off the LED. Turning off the LED. Okay, one is off. Turning off the other one. Okay, turning off the second one. Maybe I'm not clicking on it. Okay. Okay, so turning off the first one. Boom, I'm turning off all the 4 LED. So now let's shine up the photoresistor to see whether it's working properly or not. Okay, so 2 LED might be lights up. Yeah, you can see LED 1 and LED 4 is lights up, and this one 3 LED right now. 1, 2. Oh, like this. 3 LED is actually turning on. So everything worked properly. So when I turn it all off, it will, so you can see that the photoresistor detect the darkness, which means the lamp is not turning on. So the LED is not also bright as well. It will remain dark to let us know that the LED or the lamp is actually turning off. So this is my home automation project for my final years, and I have finished the hardware but not actually standard. It actually on demo as well. The hardware is on the microcontroller board, so I will doing the schematic board and doing the volt PCB thing again and again in order to make this one look more standard, more professional, and also the application as well. I will also doing the application supported with iPhone and iPad as well. So this is the iPad version, but haven't yet integrated into the iPhone, but we'll make it simply integrated with iPhone as well. So thanks for watching. This is my home automation device between hardware and application, where it two actually communicated with each other on internet using an MQTT protocol. So thank you again for watching, and see you later. Bye.